this video, I will show you how to find the distance formula between two parallel lines. I'm going to call the first line y1 equals m times x plus b1, which m is the slope and b1 is the y-intercept. And the second line is y2 equals m, the same slope because they are parallel, times x, m times x plus b2, and b2 is also the y-intercept of the second line. Now we're gonna do a graph here. I'm gonna call one of the lines, but this is y1, and this is b1, the y-intercept. This is the y-axis. This is the x-axis. And now this one y2, b2, intercept. I want to calculate the distance between these two lines. This distance, which is the same thing, the same distance as this one. Okay, the same. Okay, now I'm gonna, instead of picking any line, I'm gonna pick a particular line. I'm gonna pick the perpendicular line to both, but the one that crosses the 0, 0 point of the origin. This one. Now, this line is y equal, the perpendicular line is the opposite. The opposite of the number is negative the number minus the number of the reciprocal, which is of the slope, which is going to be negative 1 over m. That's the slope of the perpendicular times x plus 0, because the y-intercept in my particular case is 0. And I'm gonna find these 2 points. This point here and this point here. Let's find the 2 points by making, okay, this is the perpendicular. This is the perpendicular. I'm gonna make the perpendicular line, the y equal, I'm gonna do y1. This implies that negative 1 over m times x, I don't write the 0, equals m times x plus b1. And we will solve for x. Very simple. Negative b1, I'm moving the all x's to one side, to the right, and the constant by itself to the left. It's gonna be negative because positive b1 here, negative b1 equals m. This is gonna be positive 1 over m here, and because x is a factor of both, I mean x is a factor, times x, and then we have implies negative b1 equals, I'm gonna solve this fraction, over 1. This fraction is gonna be m is the denominator, the least common denominator, and then it's gonna be m squared plus 1, everything multiplying by x, and we solve for x equals negative b1 over times m, because I'm going to the m is going multiplying to the other side, and the m squared plus 1 going dividing to the next, to the other side, which is m squared plus 1 here. I have the x1 of the first point, and now we have the x bar, which is negative b, point 1, negative b1 m times m over m squared plus 1, comma, and then we have to get the y, but we can get the y for either of the equation of the lines. If x is this, I'm going to get the y, I'm going to multiply the x by negative 1 over m. If I multiply this x by negative 1 over m, multiplied by a negative, we get a positive. Divided by m, this m is going to disappear. I mean, the answer of the y is going to be b1 over m squared plus 1. Now we have the first point. By similarity, we have the second point. The only thing that is going to change is the y-intercept. For the second line, it's going to be negative b2 m over m squared plus 1, comma, b2 divided by m squared plus 1. And that's the second point. Now, using these points, I'm going to apply the distance formula. The distance formula, the distance between 2 points is, the distance formula is the x1 minus x2 to the second power plus y1 minus y2 to the second power. Now we're going to apply the distance formula. x1 minus x2, let's do it here. x1 minus x2 equals negative b1 times m. Okay, these denominators are the same. I'm going to write a big line here. It's going to be m squared plus 1 minus negative b2 is going to be positive b2m m here. Remember, we have to square that. Squaring this. And you see here, m is a factor, which is going to be m outside, but there's a square here, it's going to be m squared. Then we're going to have b2 minus b1, b2 minus b1 over, of course, square, over m squared plus 1 square. That's x1 minus x2 squared. Let's do the y2, y1 minus y2 squared. Okay, let's do the y. Same thing with the y. The y have the same denominator, which is m squared plus 1, which is going to be m squared plus 1. In the denominator, there's no m. It's going to be negative b1 plus b2. Everything is square here. I don't need so much space here. And the y1 minus y2 will be square. It's going to be b2 minus b1 to the second power divided by m squared plus 1 to the second power. Now we need to add these two. These two need to be added. We add this, and then we have to apply the square root, of course. Let's add that first. We add this, we're gonna have, and let's write the whole thing. M squared b2 minus b1 square divided by m squared plus 1 squared plus b2 minus b1 squared over m squared plus 1 squared. You can see that we have the same denominator here. And also we have, let me see, common, we have the same denominator. And we have this common on both fractions. Now we can factor things here. I can factor out these two. I'm gonna rewrite it outside. It's gonna be b2 minus b1 to the second power in the denominator, multiplying m squared plus 1, m squared here, and there's a 1 here, there's a 1 here, plus 1, divided by the whole denominator, which is going to be m squared plus 1 squared. And you can see here that this square plus 1 have a first power here, and this have a second power here. And the answer for this particular addition is b2 minus b1 squared over m squared plus 1, because one of them is going to cancel the other. And now we have to apply the square root to this. And we apply the square root to b squared, b2 minus b1 squared divided by m squared plus 1. The square root, this is the absolute value, because this is the distance. The absolute value of b squared, b2 minus b1 divided by the square root of m squared plus 1. And this is the distance formula between two parallel lines. Now, why the absolute value of the square root of x is the absolute value of x, because the square root of x is x minus 0 plus 0 minus 0, x minus 0 square. Sorry, the square root of x squared is the absolute value, because this is x minus 0 square plus x minus 0 square, x minus 0 square plus 0 minus plus 0 minus 0 square. Now, and this is exactly the distance between any point, any number in the x-axis to 0, right? Okay, because in the axis, your x, it's not x, it says comma 0, because there's a y here. And in the plane, you know, and then 0, it's not 0, it's 0, comma 0. And you apply the distance formula here, you get the absolute value. But going back to the, that's why the square root of something to the second power, the answer is absolute value here. Okay. Let's do here again. The distance between two parallel lines is the absolute value of the difference between the y-intercept divided by the square root of the slope square plus 1. And that's the answer. Thank you.